Welcome everybody to today's webinar on native cloud defenses versus Kubernetes attacks. Here at Cymulate, we believe that having your K8 cluster KO'd by a threat actor is not okay. My name is Paul Ashwood. I'm the Senior Product Marketing Manager here at Cymulate, and I'm joined today by Alan Kalendarov, who's a security researcher in the Cymulate Threat Research Group and a member of the Kubernetes Research Project team. In today's session, we're going to talk about the fact that Kubernetes clusters are under attack by threat actors, which was the driving force behind our Kubernetes research project because of the critical nature of Kubernetes environments. We'll go over the results of our research, which for many will be an eye-opening moment, and then provide you with an overview of the findings and our recommendations to better protect your Kubernetes environment. If you'd like to ask questions along the way, then please use the question button and enter your question into the BrightTalk platform. So Kubernetes clusters are under attack. Let's talk about that. It should be no surprise to everybody on this call that Kubernetes has really become the de facto standard for deploying applications in the cloud. As organizations are really looking to run business critical applications on Kubernetes clusters, different workloads, hosted by the leading cloud service providers. So there we're talking about Microsoft Azure, Amazon AWS, and the Google Cloud Platform. Just the other day, I was reading an article related to Chick-fil-A. Chick-fil-A is a restaurant chain here in the United States, the southeast part of the US, and they actually have about 2,800 fast food restaurants. And every one of those restaurants is running a Kubernetes cluster. So all of their critical workloads, their critical applications used for the ordering of their food. When you see Chick-fil-A drive-thrus, there's a constant line of cars. So they have this real business critical workloads running there on 2,800 clusters across their environment. So that really kind of plays to the whole nature of Kubernetes, how Kubernetes has really become that de facto standard for anybody that's running business critical workloads in the cloud. We see that Kubernetes K8 clusters are under attack. As we look back over the last 12 months, we see multiple different examples of attacks and threats against a Kubernetes environment. The first one here, we're talking about role-based access control, or the RBAC backdoor attacks. Here we see a misconfigured K8 API server that was allowing unauthenticated requests from anonymous users. Misconfigurations in cloud security is one of the real leading factors, one of the common causes of cloud data breaches. And so those misconfigurations, here we see a misconfigured API server in the K8 environment, and that allowed that unauthenticated request from an anonymous user. That user was then able to gain information about the K8 cluster, and they used that information to then further exploit and gain persistence within that environment. So misconfigurations is kind of one of the key themes that we'll talk about today that are causing cloud data breaches. A second example here, Scarlett-Teal and the AWS infrastructure attacks, again, exploiting a vulnerable public-facing service within a K8 cluster. This threat actor actually deployed crypto mining as a decoy to distract from their primary objective, which was to gain access to the cluster, establish their persistence, move around within the nodes of the cluster, and looking to exfiltrate and steal data and credentials. And then our last example here of the Dero and Monero crypto miner attacks. So here, threat actors locating K8 clusters with anonymous access access enabled, and using that access to gain entry into the cluster, elevate their privileges, and ultimately deploy their crypto mining operations. And if you don't have the detections in place to recognize that activity, then the time at which you'll realize that considerable cloud resources have been consumed within your environment is when you receive your bill from the service provider. So K8 clusters under attack. We see lots of different attacks based on the fact that Kubernetes has really gained widestream adoption. Before we actually jump into the research project, I wanted to just spend a moment and just talk about cloud security. Cloud security is a multi-layer, or cloud is a multi-layer architecture. We leverage multiple controls when it comes to security within the cloud environment. As we look at the controls here, well, if we're talking about cloud applications, business applications running in containers, orchestrated by Kubernetes, we would typically use a web application firewall to validate security on those business applications directly. As we come down and we talk about the container and the Kubernetes layer, again, different security controls leveraging cloud workload protection platforms, cloud native application protection platforms, and of course, the SIEM plays a key role in there. The cloud could be used for running different workloads, for example, Windows virtual machines. So here we would actually use our endpoint security controls to validate those virtual machines the same way we would on a Windows physical machine. And then ultimately the cloud infrastructure security controls. And this is where we leverage the control of things like cloud security posture management. And this is where those types of tools, those types of controls will identify those different misconfigurations that threat actors are really using to exploit these types of environments. But for today, for the webinar and for the research project that we ran, our focus is on the Kubernetes orchestration and the container engine layer within this architecture. So with this increase in focus on cloud attacks, particularly against Kubernetes clusters, Cymulate decided to conduct a deeper research project to really test the native defense mechanisms of a typical K8 deployment. So I want to call on Ilan now to tell us about the Kubernetes research project that he was involved with, what the team set up, and what test scenarios they created to validate a Kubernetes environment. Ilan?
Hi guys. So we wanted to test the native security tools of each cloud vendor. We went to the vendor site and saw what types of alerts they have for Kubernetes attacks. And with that knowledge, we went and started our research. We created 29 unique attacks for each cloud vendor, and we were testing whether their native security tools will be able to detect our attacks. So in Microsoft Azure, we have Azure Cloud Defender. In AWS, we have AWS GuardDuty, and in GCP, we have GCP Command Center. It is also worth mentioning we created attacks for on-prem clusters also.
It's important to understand here that as we set up this research environment using those cloud providers, these were the native controls for Cloud Defender, GuardDuty, and Command Center. These were standard configurations that we deployed within that environment in order to do this, the Kubernetes tests.
Yeah, exactly. Okay, so as you can see, we mapped our attacks to the MITRE ATT&CK platform. We started at initial access and ended in discovery. We stopped the discovery because we wanted to ensure that we don't harm the client's environment. And we also knew that at this point, if an attacker got this far, it's game over for the environment, and he took control over most of the critical assets. The attacks you see here is a mix of what most of the cloud vendors claim they detect. They detect. So take that in mind. Let's move on.
Before we move on, Ilan, as you look at the different scenarios that we used here, these were the common types of activity that we see threat actors using. In many cases, this is privileged activity, and we're looking to see if the security controls, the GuardDuty, the other tools could actually detect this type of activity within the environment. And so, yeah, this is high privileged activity that we're looking for, the type of activity that is commonly used by threat actors exploiting Kubernetes environments.
Exactly. So maybe if we'll take the privileged container attack, that's an attack that AWS on their side claims they detect. So we took that and created an attack for it. So when we continue with the slides, we'll see whether AWS were able to detect these attacks or not. Okay. So let's take a look at the research results. So we tested 29 attacks, as I said, from which Azure detected 66%, and the AWS detected 38%, and GCP detected 24%. The average detection rate was 24%. So out of our 29 attacks, 57 were not detected. We should also point out that we created the Kubernetes environment, like Paul said, with the default configuration. We didn't change anything, and it was just the default configuration. We also need to point out that we really try to be noisy inside the environment to get those alerts, because let's say we try to obfuscate our code or maybe just to hide something, and the result was that we didn't get any alerts. So that's the thing we need to point out.
Yeah, as I mentioned earlier, there's some eye-opening results here when you look at the fact that more than half, 57% of the attack scenarios that we executed were not detected by these native security tools when we look at all cloud providers combined. So, that would be a concern for me if I was running a Kubernetes cluster. We see detection rates there. Cloud Defender did actually detect at a rate of 66%. Going down to Command Center at 24%. So the average was only 43%. And so, as I mentioned before, this is privileged activity, the sort of things that a threat actor is going to attempt within your environment. A lot of these threat actors, their goal is to remain stealthy, to execute these type of commands within your environment without getting detected. And if you're relying on these security controls as your sole source of defense mechanism, you can see the results here that about half of those activities are not going to get detected by these tools.
Exactly. So if we'll go in detail, Azure Cloud Defender had the most detection rate out of the three. It did the best job on execution and privilege escalation, but showed us significant gaps in discovery. For example, it was not able to give us any alerts. So that I think we should point out.
Yeah, I mean, obviously, Azure was kind of leading in terms of the security control here, detecting 66% of the 29 different threat scenarios that we executed against it. Some of those techniques, though, of getting through to discovery and the ability to really understand what's going on in your K8 environment, we would want to see more of those detections within whatever tooling we're running.
AWS GuardDuty was not able to detect 62% of the attacks. It had some problems, as you can see, with the persistence and defense evasion, and also credential access. But it had a nice detection capabilities in execution, privilege escalation, and the discovery scenarios.
Yeah, so once again, we see 62% not detected within the AWS GuardDuty security controls. That's kind of high for my mind. A lot of activity going undetected. We would want to be looking at that in terms of defending our Kubernetes environment, and how do we increase that detection rate would be the goal.
GCP Command Center. It had the most difficulty, I would say, out of the three, with 76% of the attacks that were not detected. So categories like initial access, persistence, defense evasion, credential access, and discovery resulted in 0 detection rate. I would say that maybe we could, if we would have been, we would have configured the default parameters for the detections, we could have maybe get some more of the detection rates, but with the default configurations, those are the results.
Yeah, and I think that's an important point to reinforce, that this is kind of an out-of-the-box deployment of Command Center, of GuardDuty, and of Cloud Defender, without doing any configuration or defining of detection rules. This is what we get. So I guess the message there is for anybody who's solely relying on these tools and using that standard configuration, that there is work to be done in order to increase the level of detections.
Exactly. So we would really suggest that organizations need to adopt more robust, maybe multi-layered security and third-party applications to enhance their security posture. So we will go over the overview of the findings now. We reviewed some recent attacks on Kubernetes and found that threat actors are easily exploiting Kubernetes environment and seeking to establish persistence. We also observed how over-provisioned access rights could lead to these environments being taken over, where, for example, let's say a regular user had high privileges, and that user got the one who hacked and led the attackers inside the environment. The native security tools and default Kubernetes alerts are quite limited and don't contain many alerts against known attacks. We can say with fairly high confidence that most of the attacks on Kubernetes would have been passed beyond the eye of the security controls. The Kubernetes architecture is fairly complex and requires more specialized tools, possibly third-party tools, like I said before. And at this point, there are likely countless Kubernetes clusters at risk, and most of the Kubernetes attacks go undetected. So threat actors really have easy time going in and hacking your environments. And yeah.
Yeah, I think one of the key points here, Alan, is failure to detect leads to a false sense of security. So if you're not seeing alerts within your environment, you're not seeing those detections, you're not aware of the activity that's occurring by that threat actor. And so that's leading you to think that everything is okay when it's actually not. You're relying on those detections. Obviously there's going to be valid activity that's occurring within the cluster, but it's that scenario where a threat actor has gained credentials, gained access and is now performing these high privilege activities, that you want to at least see the alerts and be able to investigate those and determine, yeah, that is valid activity, or no, we have a potential threat actor within our environment. So, the absence of detection does not imply the absence of an attack.
Exactly. Like, let's say, for example, we have a Windows machine and we have an EDR on it. Now we can investigate each part. If we have a malware, for example, we can see what the malware does, what kind of processes it opens. I would expect the same thing inside the Kubernetes environment from those cloud vendors.
Okay.
So I'll hand it over to Paul now.
Yeah, so let's talk about some recommendations from Cymulate. As we mentioned earlier, cloud security is a multi-layered architecture, and it really warrants employing a multi-layered security approach to how you go about protecting those environments. We talked a lot about misconfigurations, misconfigurations being a common cause for these environments getting breached. So leveraging solutions and tools like cloud security, posture management, CSPM, those tools in particular will highlight where you have potential misconfigurations across your different clusters. Tools like Wiz, and I just read an announcement today that I found interesting, where Google Cloud is potentially going to acquire Wiz, and so that's good for the Google Cloud in terms of leveraging that tool set to identify where you have these misconfigurations. Shutting down those misconfigurations is one of the most critical elements, I think, of securing your environment and your Kubernetes environment. So also when it comes to permissions, we often see a lot of privileges where we have anonymous access being granted, or we have admin access to a default service account. And those are very specific tests that we tested for among those 29 different scenarios. So paying very close attention to permissions and access control, and really implementing that principle of least privilege. As I said, we in our environment, we use the standard configuration for the Azure, AWS GuardDuty, and Command Center. But those tools have the ability to configure additional rules. I think they do require additional rules if you're going to certainly capture the 29 scenarios that we tested against. And in some cases, you may even require some additional third-party tools like a Wiz. Investing in more advanced monitoring tools and techniques, again, is a recommendation. Here at Cymulate, we do simulations of Kubernetes-based attacks. That's part of our platform. You can run these test scenarios to validate where you have detection gaps within your environment. And the other thing is really down to the frequency of running these tests. For those people that are doing things manually through pen testing, you may only get the opportunity to test once or twice a year. But for those that leverage platforms, leverage automation, you should be executing these tests on your K8 cluster with a high degree of frequency.
I would also add that if you use Cymulate to test those attacks, you could also integrate your cloud vendor, for example, Azure, and see inside of our platform whether the attack got detected or not. And then do your modifications, write your custom rules, and just execute the attack once again and check whether it was able to detect it.
Absolutely. So just going back to the multi-layered architecture, and in this case, our focus on Kubernetes orchestration and the container engine, where we leverage the Docker container within our test environment. All of these assessments and test scenarios actually exist within the Cymulate platform. The complete 29 scenarios that the research team created and used, those actually exist inside the platform, as well as other scanning capabilities that we have for Azure, for AWS, and for GCP. So you can actually, if you were to leverage the Cymulate platform, you can run these as automated simulation tests on a very frequent basis. It also gives you the ability to look at and measure over time your performance. So we do have scoring of what we found within the assessments, and you can look at that on a time scale where you actually look for drift. So you might have your environment configured, you're running these tests, you're seeing an acceptable level of risk based on the criticality of the applications you're running in your Kubernetes environment. But over time, we might start to see some drift as the configuration gets changed in the cluster, or as the threat actors get more evolved and sophisticated in how they're attacking. So we actually use that trend to look for drift away from the score that we want to be at. And based on that, implement more detection rules or additional monitoring tools. So the ability to validate your Kubernetes environment with the Cymulate platform. So with that, let's see what we have in the way of questions. So this first question, were any third-party endpoint security providers part of this testing, such as CrowdStrike?
No, we did not. We wanted to check the native security tools of each cloud vendor because we saw that those were the most popular when you deploy a Kubernetes cluster.
Okay. We have a second question here. You may be covering this later, but did you run the same tests with optimized or enhanced security features enabled?
So yeah, well, I think we already answered that we did just the default configuration.
Yeah, and that is important to understand, default configuration, and you can implement more detection rules within these tools in order to highlight that sort of activity. We have another question here on how frequently should you validate security controls in a Kubernetes environment. I really think that's somewhat dependent on how mission critical the applications or workloads that you're running in the environment. If we go back to our Chick-fil-A example, they're basically running their stores off of the applications in the Kubernetes cluster. So as a recommended best practice, if you have automated tooling to run these tests like what we have in Cymulate, I would be running these types of tests on a weekly basis, and I would be looking at that trend of the score over time, looking for drift away from what we would consider to be an acceptable risk. So yeah, I mean, weekly and basically as often as you can, depending on whether you're leveraging automated tools like Cymulate or you're doing manual testing. The next question here, did the research also look at prevention rates? And I think the short answer is yes, we did. I'll call on you, Alan, to talk about prevention rates versus detection rates.
Yeah, so we noticed that every time we got detected by the native cloud vendor tools, we also got the prevention, because when you have the rule already applied, they know how to prevent it. So even if I'd say, develop a new rule, they will be able to prevent it, because they have agents inside your cluster that can actively run code and prevent whether the attacker is executing code on a different node inside the cluster, or it doesn't matter what the attacker does. They have agents inside the cluster that can prevent it.
Yeah. So yeah, it's an interesting topic, prevention versus detection. Obviously, prevention is good. Having the tools prevent a particular activity or action is good. But if you don't have detection, if you're not aware as a security operations team that there is threat activity going on within your environment, that's what leads to that false sense of security, right? And here we have these very stealthy threat actors getting inside an environment. Their goal is to remain evasive, evade these security controls, and just because one thing got prevented doesn't mean that they're going to try other different techniques and tactics, which is why we tested a full range of 29 different techniques and tactics across the MITRE framework. So, our focus on our research was detection. We wanted to make sure that even if the tools were preventing, that we would see detections, we would see alerts, and we would ultimately be aware that there is potential threat activity going on in the environment. We have one more question here. How can we get more detailed information about the tests performed and the results? So that's actually a good segue to our next slide here. If anybody would like to download the full report, you can simply scan the QR code here. Within that report is the appendix that has the full detail of the 29 different test scenarios, the testing protocols that we actually wrote into the Cymulate platform. Like I said, those tests exist within the platform, so any customer of Cymulate who's a Kubernetes, who runs a Kubernetes environment, can leverage those different assessments for their environment. And anybody who's interested could go out to cymulate.com if you would like to see a demo of this, and simply click on the book a demo button. We'd be more than happy to walk you through all the different scenarios, run that and see the findings from, at least from our lab environment. So with that, if there's a key takeaway, that the cloud native security tools alone are really not sufficient to detect the type of threat activity that's being commonly used by threat actors within a Kubernetes environment. As I said, as we've talked about, we're talking about the default or the standard configuration of those tools. There is more work from those people that are administering the tools, the cloud providers that own those tools, and really the security community as a whole, to really advance those tools, advance the detection capabilities within those tools, to better defend our environments. So that's all we have for you today. I want to thank you, Alan, for giving us an overview of what your research team did, and to everybody out there who is running a Kubernetes environment. Hope you found some value in this, and feel free to reach out to Cymulate if you have any more questions. Thank you.
Thanks, bye.